graph this function, we're going to use completing the square in a new way. So what we do is we isolate the x squared term and the x term from the constant term. We just move it over. We haven't changed the value of anything. And then we're going to figure out what we need to add here to make this trinomial be a perfect square. And of course, whatever we add here, we're going to take away over here, because all of this action is taking place on the right-hand side of the equal sign. So if we're not going to change the function, whatever we add, we have to subtract. And what do we add? Well, it's the same key idea. You go to the coefficient of the x, you cut it in half, which means divide it by 2, and then you multiply that by itself. So 16, adding 16 is what will make this be a perfect square. So we subtract 16 over here. Notice the 16 minus the 16 is 0, so we haven't changed our function any. We've just changed the way it looks. So this is x plus 4 times itself. X plus 4 times x plus 4. It's a perfect square. That 16 made it be a perfect square. And then we have 4. So comparing this to our a times x minus h squared plus k idea, since a is positive 1, our parabola is going to open up and be normal thickness. And we need to know where the vertex is. The vertex has a y value of 4 and an x value that makes this parenthesis 0, and negative 4 is what makes the parenthesis 0. So when we go to sketch this, we need x equals negative 4, y equals positive 4. That's the vertex. And there's kind of a normal upwards thing. Let's go to Desmos and see if that's correct. Notice it looks correct. We have a negative 4 down here, a 4 here, so the vertex is at negative 4, 4, and it's going upwards, so that's pretty good. We're going to use the same idea of completing the square on this problem, but it's a little harder because a is 2, and that gives one extra tricky step. So let's get going. Completing the square only works when there's a 1 in front of the x squared. So what we do is we bring that 25 over again, but we factor out a 2 from the first two terms. So if you look at what I've written here, h of x equals 2 times some stuff in parentheses plus 25. If you distribute the 2 through the parentheses, you get back to where we were. So I've again changed the way this function looks, but I haven't changed its value. Now we're going to complete the square here, and then whatever we need to do to adjust the situation, we'll do over here. So let's give ourselves a little bit more room. And let's complete the square. We go to the coefficient of x, which is negative 8. We cut it in half, which is negative 4. And then we multiply that by itself, which is 16. So just like the last problem, we put a plus 16 here. But do you see what the problem is? The problem is that we don't come over here and subtract 16. That's not going to work. Because when we put a 16 down here, we weren't adding 16 to the right-hand side. We were adding 2 times 16. We were adding 32 to the right-hand side because there's a distributive property going on here. So if we're going to add 2 times 16 to the right-hand side, then we got to subtract 2 times 16, which is 32. So let's take a look at what we now have. We have a 2 times, this is x minus 4 times x minus 4, or x minus 4 squared, and this is 25 minus 32, which is minus 7. The vertex has a y value of negative 7, has an x value of positive 4. It's the number that makes this parentheses be 0. The quantity in the parentheses 0. And the 2 means it's going to be slightly steeper. So where's the sketch going to be? Well, 1, 2, 3, 4. 3, 4, 5, 6, 7. At 4, -7, it's going to be slightly steeper and up. That's a good enough sketch. It shows me you know where the vertex is. It shows me what direction it's opening, and you've made an attempt to make it a little bit narrower. That's good enough. If we want better, let's go to Desmos, armed with a 4, -7 for a vertex, and see what Desmos has to say. Desmos has to say this. You can see that it is at 4, -7. The 4 is showing up here and the -7 here, but it is really at 4, -7. If you want to, you can do this. You can zoom in or out, I guess, and see that it really is at 4, -7. And you can notice that it really is just a little skinnier. And so we're done. So this is much like the last problem, except that a is -1, and with a -1 or a minus sign, the factoring is just a little sneaky. And so we're going to put the +5 way over here aside. We're going to factor out a -1, which is a little bit tricky. And we're going to leave some space. So now, once again, if you distribute this -1 through the parentheses, you will get back to where you started. So we've changed the way the function looks. We're making it look more like this, but we're not changing the value of the function. Now we have to complete the square. And so we go to the coefficient of x, we take half of it, and we multiply that by itself. So +1 is the thing, the number, that changes this to a perfect square. It's going to be x minus 1 times x minus 1 if you factor it. Now, did we add a 1 here? Because if we added a 1, we should come over here and subtract 1. But we didn't add a 1. Putting a 1 inside the parentheses is really adding -1 to the right-hand side of the equal sign. Excuse me. So we have to undo this adding of -1 by adding +1 over here. Now, if you were to distribute this out and collect all like terms, you would get back to here. All right? That might be worth doing if you're having trouble understanding. And now we're ready to find the vertex. Where's the vertex going to be? Well, it has a y value of 6, and it has x value of 1, because 1 is the value that makes the quantity in the parentheses 0. So where's 1, 6? 1, 1, 2, 3, 4, 6. Now, since the absolute value of this is 1, it'll have a normal thickness, but since it's negative, it's going to head down with normal thickness. That's the idea. So armed with our 1, 6, let's go over to Desmos and see, sure enough, we're at 1, 6, and it's opening downwards, and it has normal thickness, and we know we're correct. At first glance, this problem looks pretty good because our a value is 1. But look what happens when we try to do the completing the square steps that we've done before. We get x squared plus 3x, and we move over the minus 10. But when we try to complete the square, we've got to start with the coefficient of x, which is 3. We have to cut it in half. Use fractions here. 3 cut in half is 3 halves. And when we multiply 3 halves by itself, we get 9/4. And if you're a hater of fractions, you're going to think that 9/4 is really, really ugly. And it is a little ugly. But we have to follow through anyway. We've added 9/4. There's no distributive property here, so we've added a 9/4. So over here we have to subtract a 9/4. That's just the way it is. And now we have g of x equals And this needs to be a perfect square. Normally we don't factor stuff like this with a fraction. But if it's a perfect square, if it's something times itself, it's pretty clear where it's coming from. Because we know the 3/2 times this 3/2 gave us the 9/4. And 3/2 plus 3/2 gives us 3. So that wasn't too bad. Over here we need to turn the 10 into fourths. So notice I multiply top and bottom of 10 over 1 by 4 and I get 40/4. And so now we're ready to put this into this form. So we have x plus 3/2 squared minus, and this is 49/4. So where's the vertex? The vertex is going to have a y value of minus 49/4, and it's going to have an x value of negative 3/2, because negative 3/2 is what makes this quantity inside the parentheses 0. Now I would accept that answer for a vertex because it really is a good answer. But if we're going to graph, we probably need to regroup these. So 2 goes into 3 one time with a remainder of 1. So this is another name for this improper fraction is negative 1/2. And here 4 goes into 49 12 times with the remainder of 1. And so another way of writing our vertex is that it's at x equals negative 1/2 and y equals negative 12 1/4. Since there's a 1 here, it means it's going to have normal thickness and open upwards. So where is x equals negative 1/2? Well, if that's negative 1 and that's negative 2, it's right here. But where is y equals negative 12 1/4? 1, 2, 3, 4, 5, 6, 7. Better scroll. 9, 10, 11, 12, 1/4. So it's somewhere about here. It's 1/2 to the left and 12 1/4 down. Then it's got normal thickness. So I think that's good enough for a sketch. And the vertex, we could put in that x equals negative 1 1/2 is the line of symmetry or axis of symmetry, but I don't really think that's helping us too much for what we need to do. Let's go over to Desmos and just check this vertex and check the direction just a little bit. And sure enough, we're at negative 1/2, negative 12 1/4 for vertex, and it's opening up, and we've done a good job.